Okay, so it is now recorded. We are good to go. Again, a very good evening to all of you. 5R Kid, 5 Binary, and 5 Citrin. So far, we have 22 students here. Okay, so this is chapter 7 under theme Modern Physics. So the topic, the chapter is quantum physics. So for this chapter altogether, there are 3 learning standards. So for tonight, for this evening, we are going to cover the first learning standard 7.1, quantum theory of light. Another two is photoelectric effect in 7.2, and then 7.3, photoelectric effect, Einstein photoelectric theory. Okay. So actually the gist of this chapter is about photoelectric. Itu kandungan utama dia. But before we go to photoelectric, it is better if we know first how is this quantum theory of light started. Okay, and who are the physicists involved in the development of this quantum physics. Okay, students, so as you can see in your screen now, this lesson is covered in your textbook, started from page 224 until 231, formative exercise 7.1. Okay, so what do we have here? This is a new syllabus, a new chapter in a new syllabus KSSM. It sounds like challenging, but actually it's not that challenging. Sebenarnya tak berapa susah. Okay, because actually this chapter we learn a lot in university level, in the matriculation level. So now they are bringing it to school. Okay, so I think it's a good exposure to not only to you but also for us as a teacher. Okay, so this is the first learning standard. Altogether, we have 5 learning standard. Okay, the first one is to explain the initiation of the quantum theory. So, who initiate? Siapa yang memperkenalkan teori quantum ini? Okay, who are the physicists related? So, before we go to the story, okay, so this is about quantum theory of light. Okay, so better if you understand first. I believe you already understand. We learned this from last year. What is light? It is an electromagnetic wave, okay, which produced from the vibrations of electric field and magnetic field, which is perpendicular to one and another. Okay, and light is considered as one of the electromagnetic field in the electromagnetic spectrum we learned last year in 5.7. If you remember, ingat kan ada belajar. Okay, student. Okay, this is also you have found last year in chapter 5. Okay, this shows spectrum, light spectrum in a continuous form. Okay, continuous means what? You can see that, okay, how to understand this spectrum. Okay, this is all the electromagnetic wave. Okay, we have radio wave, microwave, infrared, visible light there with the 7 spectrum of color, followed by ultraviolet radiation, X-ray, and gamma ray. And how are they arranged? So they are arranged in order to the increasing frequency. If you go from the right to the left, okay, radio wave with the lowest frequency wave. Okay, meanwhile, if you move to the left of this graph, so gamma ray has a highest frequency wave. And talking about the wavelength, they are the opposite. Okay, remember wavelength is inversely proportional to the wavelength inversely proportional to frequency. Radio wave has the longest wavelength. Gamma rays has a shortest wavelength. Okay, welcome Chunya. We've just started. Okay, now I've explained to you the electromagnetic spectrum. So it shows a continuous form. Continuous means you can see there is no exact difference between all these light. They are all continuously arranged from one and another. Okay, there are no obvious gap between them. Okay, it's what we call continuous spectrum. Okay, then students, okay, you can see there is a notes I jot down there. Okay, as I mentioned just now, the frequency is inversely proportional to wavelength. And when we talk about frequency, normally when you are talking about wave, the frequency represent what? The frequency represent what quantity in the wave? Frequency represent energy. Yes, very good. It tells the amount of energy in the wave. So a wave with a high frequency, we understand it has high energy. And we learned before, energy is directly proportional to temperature. In chapter 4 also we learned in gas law. Okay, when temperature increases, energy increases. So what we understand from this, if you look at the visible light, there are 7 spectrum of them started from red, followed by orange, yellow, green, blue, indigo, and violet. So red light has a lowest frequency, right? Red light has the lowest frequency, which means it has the lowest energy among the 7 spectrum in visible light. Meanwhile, blue has the highest frequency, blue light. So blue light is the hottest, okay, among 7 spectrum in visible light. So you can see there, cold object emit wave with low frequency, such as radio wave and microwave. Whereas a hot object emits wave with a higher frequency, such as visible light and ultraviolet radiation. Okay, next. Okay, if you go to your textbook on page 225, you will find this graph. Okay, this is a graph of radiation intensity on the y-axis against wavelength on the x-axis. Okay, how to understand this graph? Why the pattern is this way? So actually very easy to understand. Okay, to understand this graph, let us take a look at this few example. Okay, it's written there, the higher the light intensity of a black body, the more light energy it emits. Later, we will discuss what is meant by black body. Okay, students, you take a look at this example first. Okay, this is the spectrum of our electromagnetic wave I show you just now. Started from radio wave on the right side and ended with gamma ray on the left side. Lowest frequency radio wave, gamma ray with the highest frequency. Okay, so this is the first example. You know what is this, right? A smartphone. Okay. So you know that your smartphone emit wave. Am I right? What kind of wave emitted by your smartphone, students?
I think it's infrared.
Infrared. Any other answer? Gamma. Radio. Actually, if you look from the screen, it emit microwave. Okay. But can you see the wave coming from your phone? The longer you use your phone, it will getting hotter, right? Means more microwave it will emit. We cannot see microwave because it is a non-visible light. Okay, this is microwave. Okay, so there is the light. You can see the light does not fall into our eyes, so we cannot see any wave coming from your handphone. But we understand there is a wave emit from them when you are using them for a longer time. Okay, then second example. Okay, this is actually what is this? This is human body. Okay, 310 Kelvin is our normal body temperature. If you convert into Celsius, so what is the temperature of a human body? 310. It will give you 310 ini ya 36, 37. Okay, you minus with 273, so will give you 37. Okay, 37 is our body temperature, normal body temperature. Our body emits radiation, emits wave. Okay, what kind of wave emit by our body, students?
Infrared.
Okay, infrared, you can see there. So where infrared lies, can we see infrared coming from our body?
Cannot.
Cannot see because infrared again, it is not visible to human eye. Tak boleh nampak. But actually you can see infrared when you are using thermal radiation camera or infrared camera as seen in this diagram. Okay, so you can see it's appear like a heat. Actually, there is a infrared, okay, emit by our body when our body temperature is increasing. And anything you cook in the kitchen, okay, your pan, your wok, when they are gain temperature, they also emit infrared. Okay, and it also used in your remote control for television. Okay, so what do you understand from the telephone and from the infrared from human body? The temperature is increases, so do the frequency. So the graph is moving to the left. Okay, next, this is example of lamp with a temperature of 2000 Kelvin. So you can see the temperature is increases, the frequency also increases. Okay, now this one fall in this bench, in this range, visible light. That's why you can see a light coming from this bulb. Boleh nampak kan dia punya lampu? Okay, you can see because it is visible light. That's why we can see a light coming from this band. Okay. Why red light is the fastest? Why red light is the fastest? What do you mean fastest? Fastest than who? All light travel with the same velocity in vacuum, 3 times 10 to the power of 8. Okay, okay, next students. Okay, take a look at the next example. So what is this? What do you think is this? Is this? This is a sun. Okay, this is the sun. You can see the temperature increasing now to 4,000 Kelvin. Okay, so do the frequency. Okay, sun falls where? Also at the visible light. That's why you can see the sun. Okay, you can see the sun up there. You can see a light coming from the sun because it emits visible light. Okay, at the temperature approximately about 4,000 Kelvin. Okay, now we go to the next. This is white star. Okay, look at the temperature of a white star, 5,270 Kelvin. It ranging here in this spectrum. Okay, also appear as a visible light. So you can see a white star, okay, at night. Okay, then another star, a blue star. This is the hottest star, blue, 7,000 Kelvin. So it falls here, okay. It is falls here still under visible light. So we can see blue star up there, okay. So from all the example I shows here, this is how we can understand this graph, okay. So from the range I show you just now, this is how we plot, okay, for the handphone, human body, and this is the lamp, the sun, the white star, and then the blue star. So if you look at the pattern, it is similar to the graph I show you just now, right? Sama kan pattern dia, it is increasing. Okay, the intensity, radiation intensity increasing from the right to the left side of the graph. If you understand this graph, it is shows wavelength, students. So wavelength, remember, inversely proportional to frequency, right? So if you are moving to the left, it shows that the frequency is increasing from radio to gamma. So we plot based on the ranging of temperature I showed you just now. Okay, so what is the problem with this graph? This is the graph plotted by classical theory of physics. Okay, classical theory of physics. Yes, okay. According to classical theory of physics, electron vibrating at the same frequency should have the same energy content. Okay, they say energy flows continuously, bergerak secara selanjar. Okay, this is what they mention in classical theory. And they also mention the vibration frequency of electron has no limits, which means that this graph will go higher up until it reach infinity. Okay, which is actually impossible. Okay, if according to classical theory. Okay, so if you extrapolate this graph, it will go to infinity. Okay, as mentioned here, light produced by vibration can reach unlimited high values. But what is the problem? When they are conducting experiment, the come out doesn't match with this graph. Ya, tak sama. Okay, mean experiment conducting involving black body radiation. So it is inconsistent. It doesn't match with this graph, okay, with this graph of classical theory. Because based on the experimental data, what they find, the light intensity on the left side, mean this side of the ultraviolet, does not continue to increase. It will somehow will drop back. Okay, will drop back after ultraviolet. So this is what cannot be explained in classical theory of physics. Okay, they cannot predict what happened after here, after the ultraviolet range. Okay, so and this is what we call as a ultraviolet catastrophe. Okay, this is the graph for classical theory. Okay, it will continue increasing until infinity. Okay, and it doesn't match with the experimental result conducting by the physicists at that time. So they cannot explain why it doesn't match. Okay, and then somehow later you will see. Okay, this is the classical theory. The person involved in the classical theory of physics. We have Isaac Newton there. known well in not only in gravity but also in calculus. We have Thomas Young there. You know, it is very well known with this Young slit experiment. John Dalton and J.K. Thomson is the first who find the structure of an atom. Okay, so this is Thomas Young. What is his problem? Unable to explain the radiation spectrum produced by black bodies. So he cannot explain what happened after ultraviolet. Okay, why the graph supposed to be lower down, but according to what they find, it will be increasing until infinity. Okay, so then who's come after this? Okay, before we go to the new graph invented by a new physicist, let us look first what is meant by black body, students, because the graph you see just now refer to a black body. So what is a black body? Is it a material black in color or how? Black body. Black pink. Black body. Okay, as you can see from my screen, black body refers to any object. Any object which is able to absorb all electromagnetic radiation or electromagnetic wave, falls, or this. So when I mention electromagnetic radiation, you must know electromagnetic radiation means the radio wave, gamma ray, microwave, visible light, ultraviolet, and so on. Okay. So it is a body that able to absorb all electromagnetic radiation that falls on it. In your textbook, they give you one example of a black body here. Okay, your ear cavity. Okay, they make an analogy. Actually, our ear cavity is not really a black body, but they just make an analogy so you can see how is a black body looks like. Okay, so why they call ear cavity as a black body? So the rays light that enter the ear cavity undergo repeated reflection inside. Okay, in the inner wall of the ear cavity, and its reflection, parts of the ray will be absorbed by the inner wall of our ear until all rays are absorbed. Mean it won't come out from your ear hole. So that's why they consider ear cavity acts like a black body. Okay. So you know the meaning. Any object that able to absorb electromagnetic radiation that falls on it. Okay. And at the same time, student, a black body can also emit thermal radiation depending on its temperature. Okay, as you can see on the short animation here. So they are not only absorb all electromagnetic radiation, but at the same time, when the temperature increases, they will start to emit radiation. Ia akan keluarkan radiation. Okay, and thus we say an object emitting electromagnetic radiation, which determined by the temperature, we call them as a black body radiator. So there are two things that black body absorb all electromagnetic radiation fall on them. Another one as a black body radiator. They can emit radiation when the temperature is increases. So are you clear for the first point, black body? What is a black body? Okay. Emit radiation is not based on their temperature. That's why we cannot call them as a black body radiator. Okay. So this is example of a black body and non-black body, students. Okay, we have let's take a look at example. Okay, we have two things there, a red ball and then a black ball. Okay, if you radiate a light into a non-black body, so what happened? They will reflect light. Okay, so as this ball is a red color, so it will absorb all other color and will be reflect red light. So red light will enter our eyes, so you will see it as a red color. Okay, if it is blue color, so it will absorb all other color and will be reflect blue. So we will see it as a blue. That is a non-black body. Okay, for this one, a black body, okay, what happened? When lights fall on them, it will absorb 100%. Okay, so it shows no reflection. Okay, and at the same time, when you supply heat to the black body, okay, so the temperature is increases, so you can see the color is started to change. Okay, they emit radiation. So now, for example, in this situation, the black body, which is initially black in color, actually it doesn't need to be black Okay, black body tak semestinya dia warna hitam. Itu you kena faham. Okay, so this one we supply here. So now the color is changes. It is glowing like metal. When you hit a metal, it will started to glow. So it emit radiation. So we call it as a black body radiator. So now you can see at a certain temperature, the color is now become red. Okay, so it become red because it emit radiation. For this one, it appear red because the color is red, not because of the thermal it emit. For this one, it appear to be red in color as the temperature increases because it emit a red radiation. Okay, not emit any radiation in electromagnetic spectrum, but only emit heat radiation. They absorb all electromagnetic wave and they emit radiation. Okay. Next, okay, students, can you tell me, I give you a few example now. Can we call this thing as a black body radiator? This is LED lamp. LED lamp. Light emitting detector lamp. Can we call this as a black body radiator? What do you think? Yes or no? Yes or no? Just give your opinion. Salah tak mengapa? No, this one is not a black body radiator. Why? It emit light, but the light emit is due to electroluminescent effect. Apa itu electroluminescent? Dalam itu ada LED. LED ini is a light emitting detector. It applies with a semiconductor and transistor. So it doesn't work based on temperature changes. Okay, it works based on semiconductor and transistor circuit inside. So it is not a black body radiator. Okay, how about the second example? What do we call this insect as? I tried to find the name but couldn't find in English. We call it as kelip-kelip or kunang-kunang in Bahasa Melayu. This insect, do you think it is a black body radiator? It emits light there? Black body radiator or not? This one. Actually, this is also no. Okay, ini bukan. No. It emit light, but the light emit is due to bioluminescent effect. Okay, bioluminescent ini refers to biology process lah occur inside. Okay, the reaction occur, biological reaction occur inside the body of this insect. So it does not consider as black body radiation because it emit light not because of the temperature change in its body. Okay, next. Okay, how about this? A moon. Moonlight. Is moon a black body radiator? What do you think? Moon. Yin Ho Chong. Fire. This is not firefly. Bukan firefly. Okay. Moon. Yes or no? Also no. Okay. It emit light, but the light is coming from where actually? What light is emitting from the moon?
Infra.
Ada. Itu actually reflection of the sunlight. The moon reflects sunlight. Okay, so that's why you can see a moon. If there is no sun, you cannot see any moon. Okay, it reflects the light from sunlight. Okay, it's only show reflection of sunlight. Okay, next, this one. Yes or no? Okay, yes or no? Okay, any of your family work as a blacksmith, tukang besi? Okay. Okay, so this is yes. Okay, so this is yes. Why? Because the light emitting from this metal is due to its high temperature. Okay, so this is a few example of black body and non-black body. Okay, another example, student, human body. Our body, can be considered as a black body radiator or not?
I think yes.
Okay, yes. Okay, so yes, because why? When our body temperature increases, as I mentioned just now, we are emitting infrared radiation. Okay, we are emitting infrared. Ini as seen on the infrared camera. Ini normal. This is the temperature. They are having a fever now, these two men. Okay, so their body emit a lot of infrared. If you see from infrared camera, the red part itu shows the temperature there is higher. Okay, normally when you look through infrared camera, our internal organ, your vital organ, that part normally got high temperature compared to other parts of our body. Okay, and which parts that sweat a lot also shows will be red color there. Alright, so this one, yes, because the radiation emitted is due to body's temperature. Okay, so now from this activity, what can we understand? Okay, first, white surface is a good light reflector. Okay, you can see. Mirror also is a good reflector. Mirror is not considered as a black body because almost 90% of the light fall on the mirror surface will be reflected. It absorbs a little only. So mirror is not considered as a black body. Okay. White surface, good light reflector, good light reflector. Why? Because they absorb very little and reflect most. So if you look at this diagram, the laser pointy looks glare, so will irritate your eye if you see closer. For this one, the black surface is a good light absorber. Absorb most light and reflect very little. So you can see the laser pointer there will be less glare. Okay, and the third example here, now we understand an ideal black body is a very good light absorber. They absorb all lights and reflect none. And at the same time, student, they can emit radiation when the temperature increases. By that time, we call them as a black body radiator. Okay, so nothing much difficult. What is black body? What is black body radiator? Okay, now let us take a look at these few physicists who invent quantum physics of theory. Okay, you know there are four of them. The first one is Max Planck. We have Albert Einstein, then Niels Bohr, Louis de Broglie. Ini baca dia Louis de Broglie. Okay, Louis de Broglie, a Frenchman. So you can read what are all their contribution, especially to physics. So Max Planck and Albert Einstein introduced the concept of quantum, energy, discrete, and photon, and later Einstein expand his theory on photoelectric effect. And Niels Bohr talking a lot in line spectrum. Okay, nanti kita akan lihat. And this one, Louis de Broglie, together with Einstein, later will introduce to us particle wave duality. Okay. So black body can absorb electromagnetic radiation and emit heat or electromagnetic radiation. Dia emit radiation. Emit radiation. Okay, radiation itu it can be visible light, it can be ultraviolet, it can be microwave, it can be gamma ray, depend on the temperature. Okay, boleh ya? Okay. Next, we are not talking about heat here. We are talking about light. Okay, electromagnetic light wave. Yang 7 itu from radio, micro, gamma, visible light, infrared, and so on. Okay, they almost gone crazy, but they won the Nobel Prize. Ong Jeng. Okay, they get crazy for nothing. Okay, if you look at their family history, memanglah banyak yang sedih in terms of their family history, but they are very excellent in physics, in science. Okay, so we take a good example from them. The wet one itu kita jangan tengok lah. Okay, alright. Now that is the first learning standard, student, to understand what is a black body. Okay, next. Second learning standard, what is quantum of energy? Okay, so for this one, second learning standard, we are going to introduce with our first physicist, Max Planck. Okay. Born in year 1858, died on year 1947. Okay, so Max Planck is also called as the father of the quantum physics. Kalau father of the modern physics is Isaac Newton. So this one, father of the quantum physics, Max Planck. Okay, he introduced concept of quantum. It show energy is indiscrete. Nanti kita tengok what is meant by discrete in year 1900. Okay, and then he said the electromagnetic wave emitted by black body is in discrete form known as quantum of energy. Okay, before that, in a classical theory, they say that electromagnetic wave emitted by a black body is in a continuous form. Tenaga dia continuous form, sentiasa keluar, okay, flow all the time. But Max Planck say no, they emit energy in a packet, in a small packet, one by one. Okay, later we'll see more detail on that. Okay, then he also say energy in each of the quantum is directly proportional to the wave frequency. It means when the frequency of the wave is higher, it emit more quantum, more packages of energy. Okay, then students, okay, this is to compare classical theory and then quantum theory invented by Max Planck and Einstein. Okay, to understand classical theory, you can take this example. When you open a water tap, so the water flow continuously. So this is what explained by classical theory. They say that the energy, we understand that when a wave propagate, they transfer energy, right? So they say the energy transfer from the propagation of the wave will be moving continuously, transfer continuously. Okay, non-stop. They are flowing non-stop all the way, like how is this water flowing non-stop? Okay, but Einstein and Max Planck say no, they are flowing like this rain, drop by drop. Okay, one peck by one peck, and they call it as a photon. Dia panggil photon. Okay. What is a photon? Photon in the light energy transferred in quantum. Okay, so in a small group. So each group. Okay, then this photon energy directly proportional to the frequency. As I mentioned just now, the higher the frequency, the higher the energy quantum of a photon. Okay, so kalau you tengok sini, okay, all flow all the time. So we cannot see the energy, but this one you can see it drop one by one. So we can see the energy is flowing one by one according to their packet, single packet. Okay, then students. Okay, that's it. Quantum of energy, 4.2. Pendek saja. 4.2. What is photon? Okay, so if they ask you what is photon, it is an energy packet. Okay, because in quantum theory, we understand when the electromagnetic wave propagate, the wave transfer in a small packet, one by one. Dalam satu packet itu ada banyak energy lah, a lot of energy inside. Okay, they don't go just flow like that continuously as mentioned in classical theory. Okay, are you clear with this? The difference between classical theory and quantum theory, how does energy transfer when electromagnetic wave propagate? Classical theory say continuously transfer. Quantum say transfer one by one, packet by packet, okay, group by group. Okay?
Teacher,
Yes.
what is the quantum mean?
Quantum itu mean dia in special in one small group quantum. Okay? Kalau this
Okay.
one continuously dia in a huge crowd. Continuously mean they are in a huge crowd, in a bundle. But this one little by little. So semua energy itu they have their own packet. Packet A, packet B, packet C, packet D. Okay, packet A go first, packet B, packet C, packet D, and so on. Like that. Itu kita panggil quantum. Okay, energy quantum in a small group.
Okay.
Okay.
Each packet has different value of energy or the same energy.
Dia depends on the frequency. Okay, when they are emit.
Okay.
Okay, because actually when they travel, the frequency sometimes went higher, sometimes went lower. Okay, so actually it is not consistent all the way like explained in classical theory. Okay, now we go to the fourth learning standard first, which is photon. Okay, because photon is related with quantum. Okay, now what Albert Einstein say, he introduced the concept of photon. Macam tadilah, same to Max Planck in 1905. And he said photon energy directly proportional to light wave energy, similar with what said by Max Planck. Okay, and Einstein quantum theory of light was successful in explaining the characteristic of the photoelectric effect that could not be explained by classical theory. Okay, this one actually we will learn more detail in 7.2, what is photoelectric effect. But later I will give you a small, short introduction, what is photoelectric effect. Okay, so actually Albert Einstein expand what is invented by Max Planck. Max Planck started, he just expanding from there. Okay, then he won a Nobel Prize for that, spending other physicists' ideas. Okay, then students. Okay, physics quantum theory by Planck and Einstein. So these two geniuses are combining their brains, so this will be the product. Okay, they come up with this formula. E equal HF. What is E? energy quantum of a photon, mean the energy for each packet. Okay, H ini is the Planck constant. Ini dia derived from the experiment conducted last, so he come up with this constant 6.63 times 10 negative 34 joule second. And H ini is the frequency of light wave. Okay, so this is the first formula, E equal HF. And from this formula, we can expand some more. Okay, you learned this before in chapter 5, right? Frequency is speed divide wavelength. Am I right? From this formula, speed equal to frequency multiply lambda. Okay, so for this one, since all electromagnetic wave, they are travel at the speed of light in vacuum, so C is replacing V. Okay, so from this formula, we can also write energy equal to Hc per lambda. Okay, F frequency can be written in terms of C per lambda. So this is the second equation. If you want to find energy of a photon, Planck constant multiplied by speed of light and divide with its wavelength. Okay, for example, okay, can you try to solve this example one related to these two formula? Okay, you can jot down the formula first. E equal to HF, E equal to HC lambda. Okay, then students. Okay, we have a lamp here. Okay, this is a red lamp, and big red light. So red light ini is a one example of which one? Which electromagnetic spectrum is this red light? Where does it lies at? Red light. This is visible light. Yes, very good. With frequency 4.29 times 10 power of 14 hertz. How much energy quantum of a photon is released? How much energy is released? They give you the frequency. Okay, so how to find E? So what is the formula? We can use the first. So this is the photon, student. If you can see. So it travel in a small packet. This is what we call as a photon. 1 photon, 2 photon, 3 photon, 4 photon, 5, and a lot of photon. Okay, so they travel in discrete. Okay, one by one. Okay, so what is the formula we are applying here? E equal HF. Have you find the value? So you can press your calculator and share the answer if you are done. All right, Celine, Hangjin, Yu Hui, Wanja, you can share your answer if you are done. Okay, Yuan Han, Wei Jing as well.
Teacher, this
Yes.
photon is only applied to visible light or all electromagnetic spectrum.
Sorry, come again.
This photon concept is
Yeah.
only applied to the visible light spectrum or for whole electromagnetic spectrum.
All electromagnetic spectrum.
Oh,
Okay.
okay.
Electromagnetic spectrum started from radio wave until gamma ray. For visible light, we have set another 7 spectrum, right? The color, so you don't get confused. Apply all in all. Okay, all electromagnetic spectrum started from radio wave until gamma ray.
Can I consider this packet as a particle?
Later we will see in the wave particle duality.
Okay.
Yes, you may. You can consider it as a particle. Okay, so the answer is this. Am I answer correct? Can you check? 2.84 times 10 negative 19 joules. So this is the amount of energy released by a photon. Okay, second example, student. Yes. Okay, now find the photon energy of ultraviolet. Okay, now this one ultraviolet. The first example, we are dealing with visible light. And now we have ultraviolet electromagnetic wave with the wavelength 390 nanometer. Now they give you the wavelength to find the energy. So for this question, we can use the second example, the second formula. The second formula, E equal Hc per lambda. C is not given, but we understand all C is the same, 3 times 10 to the power of 8 speed of light. Okay, remember all electromagnetic waves travel at the speed of light in a vacuum. Okay, so what will be the answer? What will be the amount of energy? Okay, you can find. Just substitute this equation. So this is a Planck constant. This will be given in the formula list. Kalau you check, ada cikgu sudah share formula list, so you can check which formula is given, which one is not. So you kena tahulah mana yang kena hafal, mana yang tak perlu hafal. H is constant, yes. Okay, it's a Planck constant. Okay, so the answer, okay, another thing, nanometer you should know lah, what is the power, what is the prefix for nanometer? So -9, okay, -9. Planck constant is given in the exam. Check dalam formula yang cikgu bagi, ada sepatutnya ada. Okay. So the answer is 5.1 times 10 negative 19 joule. Is it right, student? Betul ke? Okay. Did you get the answer, student? Dapat jawapan? Okay, Planck constant is given, ada bagi. Okay, under physics quantum there are 11 formula altogether. Okay, they give you 11 formula under physics quantum itself. So later you check, I've shared already in your Telegram group. So nanti you boleh check semula. Okay, so yes, students. Okay, next. Okay, so we go back to this graph. Okay, just now this is the graph that we plot. Okay, the red line. Okay, the red line. And as I mentioned just now, the experiment outcome is not meeting with this theory. So the failure of the scientists to explain the radiation of a black body is known as ultraviolet catastrophe. They couldn't tell what happened after this curve, what happened when entering the ultraviolet zone. Okay, from this graph, they shows it's supposed to be increasing somehow to the infinity, but somehow from the experimental, it shows when it enter ultraviolet zone, the radiation intensity will be lower down. Okay, even though the frequency is increasing. Okay, so how to solve this problem? Okay, this is where Max Planck play his role. Okay, so he invent this formula. Dia perkenalkan formula ini. Actually, the first one, formula ini is not in our syllabus. For your information, ini tak perlu hafal Ini pun dalam formula memang tak ada bagi. But I just show you so you can understand how Max Planck able to prove this graph which follow the experimental come up. So he use a probability. Sebenarnya dia cuba-cuba saja. Okay, so he apply a formula of probability and finally he able to get the correct pattern. After ultraviolet, the curve go down. Okay, as shown in the experimental come up, and he get Nobel Prize for this formula. You nak dapat Nobel Prize, boleh cipta satu formula baru. Okay, this one. So by here, he able to solve the ultraviolet catastrophe. So case closed. Sudah dapat cerita. Ong Jeng go. Okay, Jayo so can go, Nicholas. Okay, so from this, okay, so he able to solve what Thomas Young unable to explain before. Okay, Max Planck succeed to explain radiation spectrum produced by black bodies by introducing that formula. So he get the correct pattern of the graph. After ultraviolet, it will goes down. Okay, so this is what a big contribution Max Planck give to the modern theory of quantum physics. So he proved his hypothesis. Intensity of radiation is low for the high frequency wave after the ultraviolet part. Okay. Kenapa tu? Sebab dia dapat daripada to answer that, I am not actually sure because they find out from the experiment and they find out the kamar itu is not explained briefly in this chapter. But maybe we can find another research from the net. Okay, why it shows decreasing after ultraviolet. Okay, maybe some other factors affect there. Okay, but it doesn't discuss further in this chapter. They only show from the equation. Okay, maybe they got by calculation, I guess. Okay, then tengok macam tu. Alright. Okay, that means high frequency, low radiation. Yeah, according to the graph. Earlier, high frequency, high radiation. But then after ultraviolet, the frequency getting higher, but somehow the radiation will be lower. Okay. Okay, next student. Okay, so we solved the first problem. Okay, now comes the second problem. Okay, John Dalton and J.J. Thomson, they cannot able to explain light spectrum, okay, produced by an atom. J.J. Thomson does not able to explain light spectrum also produced by atom. So who will come and save, okay, and solve this case? This is the guy. Okay, before we make the guy, we understand first white light dispersed into 7 spectrum. White light itu apa? White light itu visible light. Okay. White light, visible light dispersed into 7 spectrum of light through refraction and dispersion of. You learned this before, even in lower form. Okay. White light ini visible light. They refract when pass through this prism and separate into 7 spectrum of colors of different wavelength and frequency. So you can see red has a longer wavelength, so it refract the most. Okay. Meanwhile, violet ini has the shortest wavelength and the highest frequency refract the least. Okay, then students, next. Okay, so this is how they draw this light spectrum in classical theory, continuous. Okay, continuous. There is no exact difference between one color and another. But then in quantum theory, it shows a line spectrum. Okay, it shows a line spectrum. This one. So this is what the classical physicists cannot explain why they form a line spectrum here. Okay. So this is the guy who introduced the pattern of the line spectrum for electromagnetic wave, Niels Bohr. I believe you normally see him in chemistry book. Biasa you jumpa dia dalam kes. Sebenarnya dia seorang ahli fizik. He is a physicist. Okay. Okay, what Niels Bohr did, student, he explained the production of line spectrum by using hydrogen atom. Okay, by using hydrogen atom, Niels Bohr. He is very well known with his shell of electron, yes. Okay, then the electrons, okay, he mentioned about electron. He said that electron in an atom orbit around its nucleus on a certain shell only. Okay. I believe you all know this as you all learn in chemistry. Every electron in an atom orbit around its nucleus, they only lies on a certain shell. The first shell, the second shell, or the third shell. Each electron have their own shell. Semua ada rumah dia sendiri. But then, the transition of electron from a higher energy level shell to a lower energy level shell will emit proton. Okay. Which electron is going to move from higher energy level, later we will see. Okay, and then, okay, this is the continuous spectrum, okay, as mentioned by classical theory. So you can see there is no exact difference between them. And the spectrum is ranging from 400 nanometer until 700 nanometer. Okay, on the left ini, the shortest wavelength is ultraviolet, longest wavelength is red color. Okay, so visible light spectrum said to be continuous because no separation gap. Okay, then this is what experiment conducted by Niels Bohr. So he find this new line spectrum graph when he is using hot mercury vapor lamp. Okay, hot mercury vapor lamp. Okay, the line spectrum produced. Okay, how is this line spectrum appear? Actually, it is produced by an excited atom, said by Niels Bohr. Excited atom is a series of color line. Okay, so this is the excited atom. Okay, how the atom can be excited? Student, what is an excited atom? Can you guess? Apa itu excited atom? How the atom got excited? Atom pun boleh excited, not only human. High energy. Okay, so this is actually where this electron lies. Okay, they lies at a certain shell, okay, around the nucleus of an atom. Okay, so what is an excited atom? Or we refer explicitly to electron. So excited atom considered as, yes, a high energetic electron. Okay, when we supply energy or when the electron is heated, it gains energy. Okay, so the kinetic energy increases, so it will jump to a higher shell. So they will jump from one shell to another until the higher shell, mean the outer shell. And then what happened when they are there in the higher shell? When they are there to the higher shell, they will be not longer there. Okay, because it will uses much kinetic energy and this will cause them to become unstable. Dia sudah sangat banyak energy. So, sudah banyak energy guna, so it cannot stay there for a longer time or they will become unstable. So, what will happen when they become unstable? So, they will fall back to the lower shell. Dia akan turun semula ke bawah. Okay, the electron will fall back to the lower shell, and when they fall back to the lower shell, they will emit energy, or we call as a photon. So every time they fall back from the higher shell to the lower shell, when they jump back to the lower shell, they will emit energy. They will release energy, or we call as a photon. Ini yang kita panggil. And when they emit photon, the photon will emit in a certain wavelength. In a certain wavelength. Let's say the wavelength is 400. So 400 means the line that will appear is purple, purple color. And when the wavelength is 900, when the energy emit in the wavelength 900, you will see red line on the line spectrum. So it depends on the wavelength they emit. When they jump from higher level to the lower level, they will emit different kind of wavelength. Okay, so from there they can determine the line spectrum. So this is a few example of sources of gases and the line spectrum they emit. This is for helium. Okay, so you can see a line spectrum there. Okay, this is a neon, this is argon, and this is the line spectrum for krypton. And actually we have a few more example if you find from the net. This is the line spectrum shown by hydrogen gases. Okay, it means inside hydrogen atom, it has this electromagnetic wave, blue color, blue light, orange light. For helium, we had purple light, blue light, green light, orange light, red light, and so on. Okay, in xenon, okay, most of the light are blue, okay, blue light and orange. For neon, most of the light is orange color. For mercury, okay, it emit purple light, blue light, green light, yellow, and red, for example. Okay, this one. Act as IC. IC apa? Dia macam coding lah. Okay, macam thumbprint. Yes, it acts like a thumbprint. We have our own thumbprint. So do this sources of light. Okay, they have their own line spectrum. It is different from one and another. So you boleh panggil dia lah thumbprint. IC. Okay, the identity. Yes. Okay, then students. Okay, so from here, Niels Bohr succeed to explain the line spectrum of light produced by atom, which is failed to explain by J.J. Thomson and John Dalton earlier. Okay, so he proved a light spectrum is not a continuous spectrum, but it exists as a explicit or line spectrum and giving the ID for each element. Okay, then so settle with this problem. So again, case closed. Okay, so this is for example, as I mentioned just now, if the photon emit energy with this value wavelength of 434, so we understand blue light is produced. Okay, next student. Okay, that is with the first three learning standards, learning standard 1, learning standard 2, and learning standard 4. Okay, now we go to the learning standard 3. Explain the wave particle duality. Okay, wave particle duality. Wave as a particle, particle as a wave. Okay, so how it's that happen? Macam mana? Okay, first we can take a look at this example. Okay, you learned before cathode ray. What is cathode ray, students? Cathode ray. Okay, Cathode ray ini is an electron beam, fast moving electron. Okay, cathode ray is said to have a particle properties. Okay, because it has mass. Okay, the characteristic of cathode ray, it has momentum, it has kinetic energy, they travel with a high velocity. Okay, the question here, can cathode ray or electron shows wave properties? Okay, can it show wave properties? It is a particle. Okay, if due to the properties, momentum, has kinetic energy, but can cathode ray shows a wave properties? Okay, that is the first question. So this is our next physicist, Louis de Broglie, okay, a Frenchman, if I'm not mistaken. French ke atau mana? German, is it? French. Okay, then, okay, he said he come up with one hypothesis, okay, Louis de Broglie. Okay, he said that all particles can show wave properties. This is his hypothesis. He say all particle can show wave properties. Okay, then again together with Einstein, okay, they work hand together to postulate the idea of wave particle duality of light and all subatomic particles. Subatomic particle ini refers to electron. Okay, subatomic particle. Okay, how they do this, student? Okay, second, okay, how de Broglie proved his hypothesis. So this is the experiment conducted, okay, in 19th century. Okay, when they pass through cathode ray through a slit, okay, a double slit. So it shows diffraction and interference phenomenon similar to phenomenon occur in light wave. Okay, you understand? All wave undergoes refraction. All wave undergoes reflection. All wave undergoes diffraction and interference. Okay, so electron also shows the same thing. Okay, they project to this first slit, this one show diffraction, and then they project to a double slit, so it shows a pattern, interference pattern similar to wave, similar to light, similar to sound. So this proof electron can behave as a wave. Okay, it is not only a particle, but it is also shows wave properties which can undergo diffraction and interference. Okay, and the find out from this experiment in 1927 prove his hypothesis, and later they will use this in a constructions of electron microscope. Okay, electron microscope. Nanti kita akan tengok apa itu electron microscope. Okay, ini is another example of experiment conducted the diffraction pattern shown by electron when they pass through a thin layer of graphite. And this is another pattern show when the red laser light through an aperture. Okay, this one red laser light ini wave. This one electron. So they show same effect. So this one mentioned, this one proof electron also can behave as a wave. They show diffraction and interference effect. Okay, are you clear with this? How electron can behave like a wave. Okay, then another, okay, the other way round. Okay, the other way round. Now we talk about electromagnetic wave, electromagnetic radiation, such as light, okay, visible light is said to have wave properties because, as I mentioned just now, they undergo reflection, refraction, diffraction, and interference. The question again, can light shows particle properties? Can light behave like electron? So this is the question. So who proved this? This is what done by Albert Einstein. He has proved a wave can behave like a particle from photoelectric effect. Okay, photoelectric effect. Apa itu photoelectric? What is photoelectric effect, student? It is a phenomenon. Okay, a phenomenon where electron emit from metal surface when it is illuminated by an electromagnetic wave. Okay. Does this sound similar to thermal radiation? What do you think? Thermionic emission. Does this similar to thermionic emission? What do you think? No. Why? Kenapa tak sama? Okay, electron emission from a metal surface when it is illuminated by an electromagnetic wave. Okay, before this in chapter 5, we learned thermionic emission. If you remember, what is thermionic emission, student? It is, apa itu thermionic
Emissions of
emission?
electrons from a metal surface by high temperature supply.
By high temperature. It is emission of electron from heated metal surface relate with temperature, right? Temperature increases, then only electron can be emitted. But this one, nothing to do with temperature, okay? But it is just to do with the threshold frequency, which later we will learn in 7.2 and 7.3. So when he conduct this experiment, okay, so for example, this is the two plate connecting to this circuit. So he illuminate, dia sinarkan illuminate a light into this plate, okay, with a different color. Okay, started with red. Nothing happened, no reading. Okay, and then increase using orange color. Okay, nothing happened also. Then using yellow color. Okay, using green color, blue color. So you understand from red to purple, the frequency increases, right? The frequency of the increases. So when the frequency is high enough, so it will able to push the electron out from this surface. So by that, they will show a reading. So we understand for these properties, electron also can behave like a wave. They can transmit it. Okay, they can propagate from one place to another. Okay, so ini contoh dia. Okay, so these two find outs, okay, these two experiment, interference, diffraction, and photoelectric effect shows that light can be behave as a wave. Okay, and from this photoelectric effect, it shows that light, which is also a wave, can behave like a particle. Okay, it can travel from one place to another, moving electron. Okay, from a different potential difference, so it move from one terminal or one plate to another and releasing electron and then producing electric current. Okay, so wave also can produce electric current as how electron did. Okay, this one, photoelectric effect. Okay, then, okay, so the story is not end there. So they'll do another study, another further, then they come up with this formula. Okay, with this formula. Okay, this is the wavelength. This is again Planck constant. Okay, now P ini is the momentum. Okay, momentum of a particle. So when wave move, when a particle move, okay, wave move as a particle move as a wave. So they obey this equation. Okay, so both wave and particle obey this equation. Okay, so we can find what is the wavelength when they travel, what is the momentum when they travel from one point to another.
Teacher,
Okay, yes.
do all electromagnetic spectrum have obey to this duality or only
Yeah,
later?
all obey to this wave particle duality. All wave in the electromagnetic spectrum and not in the visible light spectrum only. Okay, in the electron. So you kena beza visible light spectrum and then electromagnetic spectrum. Kita yang besar itu electromagnetic spectrum from radio until gamma ray. In between itu kita ada visible light with the 7 color from red to purple. So all them obey this wave particle duality. Alright?
Okay.
Okay. So this one, this equation, since momentum is mv, as we learned in Form 4, momentum is mass, product of mass and velocity. So B here can be replaced with mv. Okay, ini the second formula. Okay, so either you can find the momentum or you can find the velocity or you can find the mass of the particle by applying these two equation. Okay, kita tengoklah contoh. Okay, how to apply this. Okay, you can jot down the formula alpha equal to H divide P momentum, or lambda also H divide mv. Okay, mass times velocity. Okay, next student. Okay, given momentum of an electron, okay, determine its wavelength. So they give you the momentum. So we know this is P. Find the wavelength. Okay, so this one we can use the first formula. Lambda is the wavelength. Planck constant divide momentum. So you just find this, you just do the substitution and work well with your calculator. So you will find the answer is 1.95 times 10 negative 6 meter. Okay, very simple. Okay, then ada lagi tak? Itu contoh. Itu satu contoh. Wave particle duality. So to understand wave particle duality, we can see the example in interference and photoelectric effect. Okay, any question on this wave particle duality before we go to the next part? Do we have electron microscope in our biology lab? Ada tak? Kita ada tak electron microscope? Oh, we have a light microscope only. The normal one. Tak ada. Okay. It's better if we have one so we can see what is the difference between these two, because electron microscope apply quantum theory of light. Okay, students. So this is one example of contribution to quantum theory. They applies in electron microscope. Expensive, yes, I know, very expensive. Okay. Then, okay. So this tell you the resolution and image magnification for microscope depend on the wavelength of the light used. So this is what happened in electron microscope. Okay, we are using a very high frequency wavelength. Okay, then this is the structure of a typical light microscope as we have in our laboratory, and this is the structure of a electron microscope. So what are the difference between these two? These are several properties which I found from the internet before. So you can compare. This is how light microscope, and this is how electron microscope. It is bulky, big one. Okay. This is the sources of light. Light microscope use visible light from the surrounding, but this one operate with electron beam, cathode ray. Okay, they works with cathode ray. Remember, student, cathode ray is not a light. Okay, it is a particle. It is an electron. Okay, and this is the resolution for both low resolution for light microscope and very high resolution for electron. So later you will see the image is very, very clear compared to light microscope. Okay. The specimen requires special stain, not always for light microscope, but it is need to be well taken care. The specimen need to be well taken care for electron microscope. And where the specimen is placed on, here we put in a glass slide. Okay, either living or dead. Okay, no problem. Both can be observed. But when using electron microscope, the specimen must be already dead. Tak boleh guna living specimen. Kalau living specimen dia masuk dalam tu nanti dia mati. Alright? Okay. Because a very high frequency wave there, very high energy. Okay, then student, this is another comparison. Okay. How does the image focus? This one using glass objective lens. Okay, objective lens we learned before in a structure of microscope in chapter 6, light and optics. For this one, it used electromagnetic objective lens. Okay, and for light, the image view through a glass ocular lens. Up there, we see from the eyepiece. And for this one, it is projected on the fluorescent screen. So you will see the image appear on the screen. Magnification up to 2,000 times, for this one up to million times. Okay, very, very large magnification compared to the initial size. And for light microscope, it produce color image, but only black and white for electron. Inilah a few differences between light and electron microscope. Okay, we come to our final learning standard. Okay, final learning standard. How to solve problem involving 7.1 quantum theory of physics. Okay, so far, are you doing good? Can you follow me? Can you give some response or feedbacks? Okay, Nicholas, yes. How about the rest? Okay, what do you think about 7.1? Sebenarnya tak susah kan? I see stars. What star? Blue stars or white stars? Okay. Which stars? Okay, let us try to do some example of question here. Okay, kita cubalah selesaikan beberapa soalan. Okay, using photon energy, E equal to HF, and then power. Okay, this is power. Nanti kita tengok apa itu N, what is H, what is F. Okay, then students, next. Okay, take a look at the first question. Okay, so you understand now what say by quantum theory of physics, okay, energy is exists in a discrete packet, okay, called as a photon. Okay, they move in a discrete energy, moving in small packet one by one. And this is the formula we learned before. Energy equal to hf Planck constant multiply with frequency of the electromagnetic wave. Okay, then assuming that n number of photon being emitted in 1 second. Okay, we emit n number of photon in 1 second. Then we can find the power. Okay, what is power? Power is total energy transfer in 1 second. Okay, total energy transfer in 1 second. So the power is number of photon emitted multiply with energy for 1 photon. Senang saja. Okay, energy for 1 photon multiply number of photon emitted. So we'll give you the power. So P equal NHF. Okay, then again this F can be replaced, can be substituted with C over lambda. Okay, so this is another formula you can apply to find power. Number of photon, Planck constant, speed of light, and this is the wavelength. So depend on what information you are given, you can use the first or the second formula to find power. Okay, tengok contoh lah. This is all what is this symbol represent. Okay, then next, okay, we try to do this. Example 4. How many photons are emitted per second by 50 watt green light lamp? So light lamp ini is one, green light lamp ini is one example of visible light. Okay. Frequency of the green light is given 4.59 times 10 14 hertz. So how to find the photon? Okay, number of photon. So this one is N. Okay, we are looking for N, number of photon. They give you the power P and frequency F. So what is the formula we can apply here? So first you can extract the given information. Power 50 watt. Okay, Planck constant. This is the frequency. Okay, so which means we can find number of photon by this equation. P equal NHF. Okay, so can you do the substitution and find what is the power? What is the number of photon? Okay, so we substitute power 50. This is what we are looking for, and this is Planck constant, and this is its frequency of the green light. So it will give you, we are almost finished, don't worry Ong Jeng, later you can have a sound sleep. Okay, so this is the substitution. So we are looking for N, so all this go to the other side, 50 divide by them. So please be careful when you do the substitution. Jangan silap tempat. Okay, don't divide wrongly or you will end up with the wrong answer. Is this correct answer? 1.37 times 10, 20. Did you get the same as mine? Dapat tak sama dengan cikgu? Yuan Han, did you get the same answer? Hong Jin, Zerlin, Ciki Sian, Ian, dapat tak sama? Jia Yi, Chun Chuan, Chun Yao, are you doing good there? Yu Ching, Eric, Zheng Yang, Chong Yi, Hui San. Okay, very good. Okay, so this is how to find. Okay, remember just extract all the given information and then determine what is the formula used. So you will end up with the answer. I think I can share you for a while what kind of formula you are given for this chapter. Okay, this one I show to you my screen. I'm stop sharing first, can ya? Okay, students. Okay, this one. Okay, can you see this formula? Boleh nampak tak formula ini? Cikgu tunjuk. Okay, this is the 11th formula you are given in quantum physics. The first one, E equal to HF. Okay, second, F equal to C over lambda. Third, lambda equal to H divide P. This is momentum. Ini number 4, again momentum. Ini E equal to HC lambda. This one the power, number 6, P equal to NHF. Okay, starting from number 7, ini 7.2 and 7.3. Okay, Planck constant is number 11. Okay, number 11 there. H equal to 6.63 times 10 negative 34. G ini gravitational constant. Number 9 ini gravitational acceleration. So from number 1 until number 8 ini involve quantum physics. 7.1 until formula number 6. Okay, so jangan risau, semua formula ada beri. Okay, I share to you back my PowerPoint slide. Okay. Alright. Okay, we continue. Can we continue with the next question? Boleh ya? Sikit lagi nak habis. Alright, students. This one settle. So, any unit there? Number of photon. Any unit? How many photons are emitted? What do you think? No unit lah because it is an amount, number saja. Okay, tak perlu ada unit. Oh, you boleh tulis lah 1.37 times 1020 photons. Okay, jangan pergi tulis joule, kilogram, meter per second or so on. Okay, okay, we try lah a few example of objective question. Okay, this one you can relax, nothing to calculate for this one. Okay, only the theory and concept. Okay, number 1, can you respond to me? So paper 1 ada keluar satu soalan pengiraan okay. So apa yang kita buat contoh tadi lebih kurang lah macam itu. Alright. Okay, the first question, which statement is true about black bodies? Okay, black bodies, which one is your choice? Is it A, ideal body capable absorbing all electromagnetic radiation falls on it? Or B, ideal body capable emitting electromagnetic fall on it? C, ideal body capable absorbing high frequency electromagnetic radiation? D, ideal body capable absorb EM radiation in a discrete form. So which one? Okay, this one very easy, very obvious. Answer is A, ideal body capable of absorbing all EM radiation falls on them. Okay, then second question. Okay, read the question first. All objects can emit electromagnetic radiation. Okay, the frequency of electromagnetic radiation depends on temperature of the object. Which pair is true? Mana yang betul? Temperature and frequency. Temperature high, what happened to the frequency? Okay, what is the relationship between temperature and frequency, students?
Proportional.
Directly proportional. So the answer should be A. Okay, very good. Okay, then third question. Okay, which of the following pairs correctly shows an example of radiation emitted by an object? Which one? They give you the temperature, low temperature, and this one high temperature. So low temperature object, what kind of radiation they might emit? For high temperature object, what kind of radiation they might emit? So this one you have to memorize the position of each in the electromagnetic spectrum as given on top. Mana jawapan dia? So we have radio on the right, gamma on the left. So moving to the left, temperature increases, mean frequency increases. So which one is the answer? You tengok yang pertama, low temperature object, microwave here. But high temperature radio wave, sepatutnya radio wave ini low temperature, lebih rendah, so wrong. B, low temperature is here, ultraviolet. But they give you high temperature microwave, and this is wrong. Okay, D, low temperature ultraviolet. But they give you high temperature visible light, supposed to be visible any lower temperature than ultraviolet. So the answer is, yes, answer is C. Okay, low temperature object can emit radio wave, okay, and high temperature emit visible light. So it obey this spectrum. Okay, next, number 4. Okay, I show you this just now in the first or second slide. Okay, this diagram show process occur when light radiation enters our ear cavity. So which one? We can call our ear cavity as well. Light reflector, light absorber, black body radiator, or black body. Which one? Black body radiator or black body? What happened to the light enter the cavity? Undergo multiple reflection and will be absorbed little by little by the ear cavity until it absorbs all. So nothing comes out from that's why you can see a dark, very dark, okay, very dark region there when you look inside your ear cavity. So the answer is appear like a black body. Okay, appear like black body, not black body radiator. Black body radiator that emit, that is a different. Black body that absorb, radiator that emit radiation due to increasing in temperature. Okay, next, number 5. Okay, which one is not an example of a black body in our daily life? Okay, which one cannot be considered as a black body? So the answer is D. Okay, remember a black body also can act as a black body radiator. So A, B, C is a black body radiator. So the answer is D, moon. Okay, moon is not a black body and it's also not a black body radiator. Yes. Okay, next, question number 6. Okay, which one? Light energy exists in a form of energy packets. Okay, special energy, small energy packets known as what? Continuous spectrum, discrete spectrum, black body, or photon. So this one very easy, photon. Okay, photon. Okay, question number 7, student. 2 photon, photon P and photon Q, have a wavelength for each 400 nanometer, 700 nanometer respectively. So P has 400 nanometer, Q has 750 nanometer. Which comparison is correct about their energy? So what is the relationship between energy and wavelength? Energy and wavelength is energy of wavelength, yes, inversely proportional. So shorter wavelength has higher frequency, so mean higher energy. So this means P has a higher energy compared to Q. Yes, very good. Okay, I think we have come to the last question for tonight, question number 8. Okay, again, you are given a mercury lamp. Produce purple and green light, may produce purple and green light with a frequency 7.41 times 1014 Hertz and 5.49 1014. So purple 7.41, for green 5.49 respectively. Which comparison is correct about the energy possessed? Again, they ask you for energy, but now they are giving you frequency. So what is the relationship between energy and frequency?
Directly proportional.
Yes, directly proportional. Very good. So the answer is supposed to be, which one has higher energy? Purple or green? If according to the frequency given, should be purple. Yes, purple light energy is greater than the green light energy. Okay, so I guess that's all. I don't have a star, but I have my parrots here, Hong Zheng. So guys, that's all for tonight. 7.1 quantum theory of light. What do you think?
Teacher, I have
Yes.
a great.
Okay, I off the record button first. Okay, later you can ask any question if